All right, we are day 15, making decent progress. We talked last time about how we were almost 1/6 of the way through, and today we are officially 1/6 of the way through. I don't know if that's a lot or nothing, but it is what it is. Today we're going to look at 212 and 214, and we are going to begin, like I mentioned a little bit. I have some polynomial goofs to straighten out.
Is this AAHL?
What is it?
Is this AAHL?
Yes. Pretty much as soon as you get towards the double digits of the 2.12, 2.10, most of the SL stuff doesn't really make it that far, so. We did a polynomial notes last time we talked on Friday. We talked about roots, which is really quite easy. If you plug something in and it is a root, then you should get 0 because it is an x-intercept. And if you plug something in and it does not give you 0, well, that's the remainder. No mistakes there, no issues there. But at the end, we talked about sum of roots and multiplication of roots. And I admitted, hey, I never really even heard of this beforehand, but I looked it up and it's quite easy and it makes sense, I guess, and there's no problem at all there. And so then I started teaching, and at the end of class I was like, something's not right. I don't really know what's right. And then we did some questions together, and again, I keep saying we, but I, as the teacher, I messed it up. I will take ownership for sure. So the sum of roots comes from B. And that is pretty obvious. If we have something like x plus 5, x plus 1, which is x squared plus 6x plus 5. The sum of the roots, 5 and 1, makes 6. We talked about how it needs to be divided by a. And be careful, because these aren't even the roots, really. These are the factors. The roots are -5 and -1. So the sum of the roots, -b over a. Then we talked about the multiplication of the roots. And the multiplication of the roots are coming from C. Because if you multiply -5 times -1, there it is. And we talked about also how you needed to divide this by a. We did more of an exploration as to where that a comes from. But then we started doing a cubic, and I got a little frustrated. Make sure I sort this out. Okay, cool. That we had a longer one, so a quick one, x plus 1, x plus 2, x plus 3, x squared plus 3x plus 2 times x plus 3, x cubed, and then 3x squared and 3x squared, 6x squared, and then 9x and 2x, 11x, and then 2 and 3 makes 6. Cool. Got it down right. When we did this, then we ran into a problem, because I was like, all right, listen guys, this should be the multiplication of your roots, and you divide it by a. Now your roots here should be x equals -1, x equals -2, x equals -3, and when you multiply those together, and then divide by a, and we're running into an issue here, because when you multiply these together, you get -6. And -6 divided by 1 is not what we actually have. And now I was stumped on Friday.
At this time, any 9th, 10th, or 11th grade students who have not
good?
had their picture taken, please
The
report
b
to auditorium.
being the
Again, any
sum
9th,
of the
10th, or
roots,
11th
which would
grade
be
students who have
-1,
not had
-2,
their picture
-3,
taken,
all
please
making
report to the
-6, and then negative like that. That is still working. So we feel good about this sum of roots, but this multiplication, I was like, what? Why doesn't this work? Like, it just worked for the squared. It doesn't work for the cubic. And the reality is that there's just another rule for it, which is -c minus a. And the difference is whether you are an even degree function or an odd degree function. So basically, we pretty much nailed it. Yeah, these are different, and it was different for the squared and for the cubic, and the reality is that's how it works, I guess. And I honestly just didn't realize that, and that's why we were stumped on Friday. And the good news is, when I looked it up, I thought to myself, we can handle that. So, here's where we were on Friday. Then we did this question, and most embarrassingly, we totally, again, I keep saying we, which is unfair. I totally blew this whole question and ruined the whole thing, okay? The sum of roots, the product of roots. We know that the sum has to do with B and the product has to do with C. C meaning the final term, because as we're looking at here, these terms have many, many, many things. So sometimes they even called it Z. We know that we need to divide by A. We talked about how this one needed to be negative. But then we also learned that this one kind of depends, right? If you're an even function, then you should be positive. But if you're a negative function, you should be, if you're an odd function, you should be negative. Now, what mistakes did we make? The product of the roots, this is the one that changes, okay? It should be positive for even, and it should be negative for odd. So for our first function, I don't know why it's not loading in here. I think my board's just tired today. Our degree is 4, which means it should be positive, which means we should have 4 as the product of our roots. Where's that 4 coming from? It's 8 divided by 2. Leave it positive. Then we made, again, I keep saying we, which is unfair. I made a mistake, 8 and 2, but this one is a degree 5, an odd degree. And so this one should be negative 4. Because when it is odd, it kind of has that negative that needs to come with it. Just like we saw when we were making our own problem. This one is a 10, which means don't mess with the sign at all. It's a -1 and a +1. It's a -1. We got that one right because we basically treated all the degrees, whether it was even or odd, like they were all even. So the sum of the roots, it should be the same for all of them, right? So the first one, we're going to look at B, which is 6. Turn that negative, divide it by A, and get -3. And then this one, I just have no excuse for, and I think I was feeling flustered from not really knowing what was going on during the notes and getting a little bit nervous. The answer here is not to take this 6 and cut it in half, because the B value should be the one that comes after the degree, and the degree is 5. So this is actually 2x power 5 plus 6x cubed. The B is 0 because x power 4 is just missing here. We have 0 x power 4. So like I said, that is an inexcusable mistake that I have made. So definitely my bad on that one. This one is -1, and that one is the B value, I promise. Take that, divide it by A, which is 1, and flip the sign, so that's going to be +1. And then the last piece, we got that all right, which is the remainder when x minus 1 is a factor, which means x equals 1. So what happens when you plug in 1 for x? And when you do that, plugging in 1 for x, it basically just gives you only the coefficients left, something that we, not the h, something that we did correctly. 2 plus 6 is 8, plus 5 is 13, minus 7 plus 8 is going to be kind of like plus 1, so it's going to be 14. This one is the exact same thing, and then this one would be 1, minus 1, minus 1, minus 1. Pretty sure. So I believe that we made a mistake in this position, in this position. I guess that's only it though, so maybe it's not as bad as I remember. Okay, we feel better about this? Again, I hope that I've owned up enough of the mistake. Literally, I just didn't know there was a difference. But there is a difference between even and odds. If you want a way to remember it, your even functions are like your squareds and your fourth powers, and those things eat up negatives, right? Because negative 3 squared becomes positive 9. And so maybe that's a way that you remember about multiplying the roots. Okay, let's get into something new. We do not have much to do today. That is new. We have been talking about homeworks, talking about quizzes, talking about pictures, waiting patiently for our favorite classmates to return. Something that we even and odd functions. Even and odd functions. I think we've learned this before, so we're going to go quickly. There's not much to it. It's just a, hey, remember this type thing. Importantly, even and odd functions is talking about the whole function, not even and odd degrees. We just did something that had to do with even and odd degrees. Even and odd degrees is just what's your biggest exponent. This is different. This is if your whole function could be considered even or odd. In order to be even, you need to be reflect over the y-axis. Now the best, our favorite even function is just y equals x squared, because it's nice. Simple. It does have that second degree, that power 2 degree. And honestly, when you're kind of early in math and you do this, a lot of the teachers might even tell you, hey, look for the degree. But now that we're in complicated math, it's really not that simple. Reflecting over the y-axis is more or less how it looks graphically. Algebraically, what this means is, if you put a negative x into the f, what you should get is regular old f of x. And basically what this means is that the positive x values and the negative x values have the same y values. So if that looks like gibberish math formula that you have to memorize, it's actually very straightforward, kind of common sense math, okay? This means that all the negative x's have the same y's as all the positive x's. So if you have a 7 and a negative 7, the y values should be the same, which is exactly what we'd expect. 7, 7, the y value should be the same. Good enough. Okay, that's even. Again, relatively straightforward. There's also odd functions. Odd functions reflect over. Does anybody remember for the odd functions for bonus points?
Origin.
Right, not really bonus points. Sorry, you got me. Origin, which is a little bit funky because reflecting over the origin is not a line. The origin is a point, and so this type of symmetry is called point symmetry, which is kind of weird. It's not super like natural to kind of think about just, oh, just flip it over. Line symmetry is very easy, but point symmetry is like moving in total opposites. And so if you do it with your hands, whatever direction your one hand goes, the other one has to go opposite. So if this hand goes up and left, this hand would have to go down and right. And so you have to make essentially this like spiral shape where they break out from this point and they move in kind of a spiral. So point symmetry is very weird to kind of conceptualize. Most of the time, our favorite thing is x cubed. Because as it breaks out, moving right and then curving up, on the other side, it breaks out moving left and then curving down. And those are moving opposites. I don't know, good stuff. The way this works is that f of negative x should be equal to negative f of x. We've done these two things before. Awesome. The way that you want to think about it is even functions should be able to absorb negatives. That's how I like to think about it, right? If I feed my function a negative sign, does it just eat that and say, who cares? Nothing changes. That would make it an even function. It just takes it and it just evaporates, okay? Your odd function, if you feed it a negative, it's gonna change the whole thing. The entire thing is gonna become negative. That's what makes it negative. Now, the reality is, in real life, when you have functions and you're doing data and research, this will almost never happen, right? This is just like a math teacher thing. And so, very common in real life, neither is an option, okay? Now, in math class, neither is an option, I don't know, like a quarter of the time or a fifth of the time. Most of the time, the teacher wants you to do one of these, but neither is certainly a thing, which again, is kind of weird why they call it even and odd, because when it comes to numbers, it's like, oh, well, this number is even or this number is odd. But if you think about it, like, what about like decimals, fractions? Like, are those numbers evens or odds? Like, what about pi? Is pi even or odd, you know? So neither maybe makes a little bit of sense. Okay, now, let's finish off. Again, we're trying to move reasonably paced today. Let's finish off by talking about functions and their. Now, honestly, I was thinking about a word for this. I didn't really like how it was described. Similar functions is already kind of a thing if you have like a similar triangle, so I didn't really like similar. So I'm just gonna say neighbors. Honestly, this word isn't that important. Like, you could kind of go without even really, that's not like a fancy math word, but just a nice title for notes, functions and their neighbors, okay? So, I wanna talk about how does f of x compare with 1 over f of x compared with f inverse of x, right? These are things that we've done a little bit of math with, but how do these compare to each other? How do the graphs look? What parts carry over? What parts change? How are these three things kind of in tune with each other? So, in order to do that, I'm going to leave some space here. And I'm just gonna go and start kind of working over here. Basically, just maybe leave a little bit of room on your paper so that we can go back. Let's do just a little bit exploring and kind of figuring out what's up. If y equals 2x plus 3, okay? Give me a graph of that. Anything you know about this function? Shout it out. The y-intercept is 3. Sure. Anything else?
Slope is 2.
The slope is 2. Yes, but that's only really doable because this is a line. We don't really know how to handle the slope of like a curve or anything like that. So you're exactly right, the slope is 2. But it's worth writing. The x-intercept is -3/2. I guess I'm just being picky about the slope because if this was a harder question, we wouldn't care about the slope. So I think that's pretty much good. What about y-intercepts? Vertical asymptotes, vertical, horizontal asymptotes, oblique, none of that really exists, right? Cool. We got a line, slope is 2, Grade's absolutely right. Awesome. Now, what about 1 over f of x, which just simply looks like this? Does that graph look different, similar, or very different? Well, first of all, give me something. Do we know what a vertical asymptote would be, a horizontal asymptote? Do we know what an x-intercept would be, a y-intercept would be? The vertical would be -3/2. Nice catch. And this is a vertical asymptote, right? So it's x equals -3/2. What else do we know about this? Nice, the horizontal asymptote is 0. Anything else? What about x-intercepts? We have a horizontal asymptote of 0. When we set the top equals 0, it doesn't really happen. What about y-intercepts? Do we have any y-intercepts? The y-intercept would be 1/3. Very good. Nice job. And you know what? That's enough. Draw my graph. Oh, don't cross the asymptote, please. There we go. Is this graph very different? Yeah, it's way different. This is a reciprocal graph. It's not a linear graph. However, are there numbers sticking around that seem familiar? Which numbers are sticking around that seem familiar? The vertical asymptote and the x-intercept. So here's basically what we're trying to connect today. Your x-intercept is where the top equals 0. And if you flip the function upside down, where has that x-intercept gone and become? Right, it is now on the bottom, and where the bottom equals 0 has now turned into a vertical asymptote. So this is something that I saw on questions that I thought, I don't know that that's like a super straightforward pickup. But when we look at it like this, it should be a pretty straightforward pickup. So let's go down, let's do this last bit here. Not that, that. And let's talk about the inverse. How do you find the inverse of a function? Switch the x into y, so x equals 2y plus 3, subtract 3 divided by 2, y equals x minus 3/2. Let's graph that function. Is that linear or reciprocal? This. What do you say? It's actually linear because there's no x's on the bottom, right? The x's on the bottom is what scares us. We don't have any x's on the bottom. So this is, also written as y equals 1/2 x minus 3/2 if you're addicted to the slope-intercept form and you want to talk about the slope, but does it have a horizontal asymptote? No. Does it have a vertical asymptote? No. What is the x-intercept going to be? Top equals 0, 3. What is the vertical or the y-intercept going to be? -3/2. There's no line. Again, do these graphs look exactly the same? They actually look pretty similar, yes. Are there any numbers that are sticking around? Yes, also, right? We have our -3/2 is still sticking around. We have our 3, 0 reminding us of the 0, 3. In years past, you've had to graph graphs and their inverse, f of x and f inverse.
Teachers and staff in front of your office at this point, if you have any students who need to take out the electronic
Reflect over y equals x. Because you've switched y and x. So,
also, students, if you are coming to the homecoming dance but have not paid your class,
one of our graphs
you will
looked
not
like,
be able to receive
not
your
quite that,
certificate
looked
until
like
your
that.
class dues are paid. So
Here's y equals x, so our inverse
tonight.
looked like that. Anyways, you already have learned that and known that. Okay, let's go back here, and let's do a little bit more. Let's do a little bit more. Then we'll go back and we'll finish the notes. Okay, we're gonna do the same thing. We're gonna do 3 graphs of an original and a 1 over the original and a inverse, except for we're gonna make it more complicated than linear. So, let's start off with y equals a fraction, and it really can be anything. Normally this is one of those things that say, you guys shout out numbers, but the announcements are coming. We're trying to go quickly. This is a rational function. We've got x's on the bottom, we've got x's on the top. It's a bit of a mess. Graphing this, who can tell me the vertical asymptote? 1/3. X equals 1/3. Nice. What about the horizontal asymptote? Nice job. Y equals 2/3. What about the x-intercept? -5/2. That's where the top is equal to 0. What about the y-intercept? -5. Again, all of that we've already done this whole lesson. We're moving on. Next up is the 1 over f of x, which is basically put the function into the denominator, which is basically flip it upside down. And so when we have a rational like this, it becomes super obvious that when we find that, we're just going to be flipping it upside down. And so the bottom's going to come to the top, and the top's going to go to the bottom. Oh, I didn't draw my graph. Done. Okay, we flipped it upside down. Let's do all the same stuff. Vertical asymptote would be -5/2. Horizontal asymptote would be 3/2. X-intercept would be 1/3. Y-intercept would be -1/5. Draw my graph. Now these ones look, I mean obviously these are rough sketches that I'm drawing and that maybe you're drawing as well. I'm trying to go quickly, but these ones do look a lot more similar than they looked before where we had a linear and a reciprocal. Are we noticing a lot of the same numbers popping up? Yes, right? Okay, cool. One last one, which is the inverse. X equals 2y plus 5 over 3y minus 1. We've done these. Multiply the other side. 3y minus 1 times x equals 2y plus 5. Distribute 3xy minus x equals 2y plus 5. Get the y's all over one side. 3xy minus 2y equals x plus 5. GCF out the y. Divide by the other stuff. Alright. It would be y equals fraction x plus 5 over 3x minus 2. We did that before. That was like the first week of school. I know that was maybe too fast, but you guys are smart. You guys get it. Very last thing we're doing. Graph this, the vertical asymptote, positive 2/3. The horizontal asymptote would be positive 1/3. The y-intercept would be negative 5/2. The x-intercept would be negative 5. Oh, did that backwards. Handwriting's getting worse and worse and worse. There's my picture. And of course, do you notice the same numbers popping up? Yes. Okay. Here's what we want. We have explored around a bit. We have looked at how these things different and how they relate. In this first one, let's look at how does 1 over f of x, or I guess, let's just list it in the opposite direction. Let's look at how does f of x turn into 1 over f of x. Okay. I'm going to write the y-intercept, the x-intercept, the vertical asymptote, and the horizontal asymptote. And I'm going to write this for both. Let's see if we can make some connections. So when we do this, we want to be looking at how do the top two, at least the way I organize it, which is kind of ugly, how do the top two relate? We can ignore this third one, which is the inverse. So the y-intercept, which was 3, what happened to that y-intercept? Where did it go? How did it change? How did that number 3 show up on the 1 over f of x? It was similar to the y-intercept. Let's look down here. The y-intercept was 0, negative 5, and the y-intercept was 0, negative 1/5. Negative 5, negative 1/5. So those are pretty similar. Now, are they exactly the same? No, they're upside down, right? So I'm going to draw a little curly Q that's going to remind me that the original and the y-intercept, you got to flip it upside down. Okay? What happens to the x-intercept of the original, which was negative 3/2? Where does that show up on the 1 over f of x? Negative 3/2 here, negative 3/2 here. I'm going to draw a line from the x-intercept to the vertical asymptote because our x-intercept turned into our vertical asymptote. Now, what about our vertical asymptote? Well, this top one didn't even have one, so that's not a very good example to look. Let's look at this one down here. Our vertical asymptote was 1/3. Over here, 1/3 showed up right here, which was our x-intercept. So I'm going to draw an arrow that looks like that. And then our horizontal asymptote was 2/3. Our horizontal asymptote was 3/2. So what happens to our horizontal asymptote? Flips upside down. Okay, so that is what happens to all of your stuff, right? I could tell you that for f of x has vertical asymptote x equals square root 3 over pi. 1 over f of x. What's the x-intercept, right? What would the answer be? Square root 3 over pi, right? So we're just recognizing how those two things are related to each other. Now let's do this last one. how does f of x relate to f inverse of x? We've got the y-intercept, the x-intercept, the vertical asymptote, the horizontal asymptote, y-intercept, x-intercept, vertical asymptote. And let's draw some lines and do some squigglies if they got to flip upside down. Does anybody know anything that's a match? Look at these two graphs and follow a number. Pick one that you like and say, where does that show up on the other thing? So, anybody got one? We've got the y-intercept of -5 becomes the x-intercept of -5. The y-intercept becomes the x-intercept. Because they're inverses. You switch to x's and y's. So that makes sense. Nice. What happens to the x-intercept? It used to be -5/2. Where did that number go? Down here. It's the y-intercept. Nice little trade there. Sweet. What about the vertical asymptote? It was 1/3. 1/3 down here is actually the horizontal asymptote. And of course, you get the picture. It's going to trade like that. Do not. Of course. Who are these teachers?
To the gym, the portables. Everyone, please do not dismiss students until we make the announcement.
Oh my God.
We might be a little delayed today. Thank you.
Feel personally attacked after that one. Okay, that's those for the day. Now this stuff, we didn't really do any questions for aware about this stuff, but these relationships here was all the work that we did today pretty much, is how those two things kind of relate to each other and how you can recognize, oh, well the inverse in the original, well the x and y intercepts are swapped, and even the vertical and horizontal asymptotes are swapped. Okay. Now, here's what we got. I got a packet. It's a bit of a big boy or big girl.